Welcome you all. So in previous videos we have discussed what is the mean by IoT. So what are the protocols which are used in IoT and the other features like application areas where IoT is enormously used. So in this video we will talk about the communication models which are used in IoT. So there are totally four type of communications models which are used. So we will discuss, and before that, if you are new to the channel, please guys hit the like button and subscribe the channel for more updates. So the contents which we are going to discuss in this session are: first, we will be discussing about request response communication model. So what is meant by request response communication model, and the block diagram for the same, and we will be discussing how it works. And similar approach is done for the second type of communication model, that is publish subscribe type, and same thing is applied for the third type, that is push pull communication model, and the exclusive pair communication model is followed same. Alright, so the function of server includes, so it is in taking the request from the client here. So the first function is taking the request from client and then giving the response to the client. So there are two input output functions here, so request and response. So receives request from client and processes the request. So it will receive the request and then it will process. So it will understand what type of request they are sending, then looks up and fetches the resources. So what are all the resources which are needed to give an proper response to the client? So that resources it will look for, and it will fetch those resources, then prepares a response and sends a response to the client. So overall it will be doing whatever it takes to give an proper response to the client. So it will be allocating the resources for the response to be created, then it will be gathering the proper information, that is the data, and it will be sending it to the client. And it will be obviously connected to the another block which is called as resources. So a resource may be a data center where a large amount of data will be produced about different types of things. So that we can take as a resource for the server. So that is how a request response type of communication model works here. So the sum of points I have listed here. So they says request response is a communication model in which the client sends a request to the server and the server responds to the request. So as I said, client will be sending the request and the server will be sending the response in turn to that request. And when the server receives a request, it decides how to respond and fetch the data, retrieves resources representation, and prepare the response here. So it is a stateless communication model, and each request response pair is a independent thing here. So stateless here, the meaning of stateless is there is no memory. So it will be, so this is one request and the response is there. So another request is made from the client and another response will be given to the client again. So this request response and the second type of request response over here are independent. So there is no connection between these two and they are independent. So that's why it is called as stateless, means there is no memory included in this type of communication model. So this is how an typical request response type of communication model works. So now we'll move on to the second type of communication model, that is public subscriber one. Alright, so here is the public subscriber communication type of model, where we will be having a publisher, broker, and the consumer. So as the name itself indicates, it is a public subscriber model, means someone will be publishing the data and someone will be receiving that data. So the subscriber is one who is receiving the data from the publisher, and in between this publisher and the subscriber someone will be sitting, that is he will be routing the data, and that entity in the communication is called as broker. So in between publisher and subscriber an individual is sitting, and that is called as broker, so which will be acting as a chain between publisher and the subscriber. So as you can see in the block diagram, so here first thing which is present is the publisher. So publisher is the one which actually produces the data. So he is the producer of data, so manufacturer of data, I can say. So sends messages to the topics. So here next thing which is present is the broker. So broker has got different types of topics, and let us say we want to automate our home, and in that we will be having temperature and pressure as the two entities. So topic 1 contains the temperature and topic 2 contains the pressure value. So we will be having different types of subtopics here. So it may be temperature and pressure, humidity, amount of light, amount of gases present in the environment, and many more things are there. So we can have different types of topics in a particular home. So if you are subscribed to a particular topic, say temperature, then we will be getting only the data which is related to the temperature changes. So if temperature changes, then that readings will be forwarded to you. And as you are not subscribed to the other topic, that is pressure, you will not get any information regarding that pressure here. So that is the meaning of topic. So in a whole nutshell of home, we will be having different types of topics, that is temperature and pressure. Let us take an example of them so that we can understand. So if you are subscribed to a particular topic, then you will be receiving only the messages which are related to that topic only, and the other messages which are there, but we will be not receiving because we are not subscribed. So it is just like a YouTube subscription. So if you subscribe to our channel, you will be receiving the videos which we will be uploading continuously. So if you are not subscribed to our channel, then you will be not receiving the updates, that is I have uploaded a new video or something, I can say. So that is the meaning of topics and subtopics in a nutshell. So here it shows a topic 1, so it contains subscribers, and subscribers are how many subscribers are there for this one? There are two subscribers, the consumer 1 and the consumer 2. So subscribers are also called as consumers here. So this is the first subscriber and this is the second one. So it contains two consumers here. And coming to the topic 2, it contains the subscriber, only one subscriber, that is consumer 3 over there. So the if there is something the data related to the topic 2 will be given to the only consumer 3, and the data which is related to the topic 1, it will be given to the consumer 1 as well as 2, because they both are subscribed to that topic. So the message of the broker here is to message published to the topic 1. So the whatever message is published by the publisher to the topic 1, it will be forwarding that message to the consumer 1 and the consumer 2. And same thing can be applied to the topic 2 also. So whatever the message is there in the topic 2 that is sent by the publisher, that will be forwarded to the consumer by the broker. So it is just like a broker, that is a middle entity which is sitting between publisher and the subscriber. So coming to the points here, so publish subscriber is a communication model that involves publishers, brokers and consumers. So publishers are the source of data, so they are producing the data, then publishers send the data to the topics which are managed by the broker. So publishers are not aware of the consumers, so it is not mandatory that the publisher should know the consumer, because only the broker will be knowing the consumers or the subscribers. So there is no need for publishers to know about the consumer. So that work is done by the broker behalf of publishers here. Then consumers subscribe to the topics which are managed by the broker. So as I said, there will be different types of topics to which the consumers will be subscribing, and the topics to which they will be subscribing, they will be getting the information regarding only that topics. So this is our typical publish subscriber communication type of model works. And now moving on to the next model of communication, so that is called as push pull communication model. So it is very simple communication type of model, we can say. And it contains first quantity, as usual the publisher sends message to the queue, and the middle quantity which is present here is the queue. So in case of publish subscriber, we will be having the broker, but in case of push pull communication model, we are having queues here. So queue is nothing but a first input first output type of stack, we can say. So whatever is put first inside that one, we will be getting it as a first output. So if you are putting one at this position, then we will be retrieving one at the other end only in the first position. So that is like a FIFO type of algorithm, we can say. So the publisher will be generating the data as usual, and then it will be pushing it to the queue. So message push to the queue here, so that message will be stored in the queue, so it is also acting as a buffer for some time, and that message or the data which is present in the queue will be pulled by the consumer. So if it is sending some temperature, say T, then that temperature will be stored in this queue, and as the many more values are present, so the T will be coming at this end as it is pushed in the queue, and it will be pulled by the consumer here. So the consumer will be pulling the data from the queue. So this is how a push pull type of communication model works. So the publisher will be pushing the data to the queue, and the consumer will be pulling the data from the queue, and the same thing applies to the consumer too. So there can be n number of consumers for the queues. So coming to the points here, push pull is a communication model in which the data producers push the data to the queues and the consumers pull the data from the queues. So as I said, the same thing is noted here. Then producers do not need to be aware of the consumer. So here the same thing applies for the publishers and the consumers. So it is not necessary that the consumer and the publisher should know each other. So if they don't know, also with the help of queue they can communicate. So just like publish subscriber, here queue is acting as a broker. So it is a type of a broker itself, so it is just storing the data, it is not doing anything else. So queues also act as a buffer. So as I said, they are also acting as a buffer, because the data which is first present in this position will be pushed until this position. So for 1 2 3 and 4, so until 4 positions the data will be stored, and then it will be pulled by the consumer here. So for that time period, it will be like a storing the data in the queue, so which helps in situations where there is a mismatch between the data rate at which the producers push the data and the rate at which the consumers pull the data. So this storage of data helps basically to solve the problem of rate mismatch. So let us say this is, that is, the publisher is pushing the data to the queue at a 10 kilobytes per second, but the consumer is only able to receive the data at a speed of 8 kbps. So there is a difference of 2 between the publisher at the rate which is the data being produced, and the consumer which is being pulled by the pulled from the queue. So that 2 difference 2 is managed by the buffer, acting as a buffer. So that 2 kilobytes of difference between the publisher and consumer is managed by the queue, as it is acting as a buffer. So for that time period it will be storing the data. So it is basically helping the publisher and subscriber to maintain their data rates. So this is how the typical push pull communication model works. Then moving on to the second or the last type of communication model, we can say, so that exclusive pair communication model. So this is this is the very typical communication model where we will be having only client and the server. So there is no type of a broker here. So what will be happening is a request will be sent to the server here. So here we are having a server, a request will be sent to the so a server establishing a connection. So to establish a connection, we will be sending a request here, then a response acting the request. So a response will be sent from the server saying that I am ready to make a connection with you, and then message from client to the server. So in the third step, the message will be sent to the server from the client. So first we will establish a connection or a link between the client and server here. So first we will be sending a request for the server to make a connection, then it will be sending an acknowledgement saying that yes, I am ready to make a connection with you. Then once the client receives the acknowledgement from the server, then it will be sending the data or the message to the server, then a message from server to the client. So it will be sending in response to the client. So whatever the data the client wants, it will be sent by the server. Then connection close request. So these two steps will be followed to until and unless the data transfer is complete. So these can be followed several times. Once you form the connection in first two steps, then we will be exchanging the data between client and server continuously. So whatever the client want to ask to the server, it will be asking, and the server related data it will be sending. So once you think you have completed your communication, and the client thinks that I don't have any data to send, then at that time, to reduce the power consumption, the client will be going to the sleep mode. So it just want to disconnect from the server. So at that time, the client will be sending a connection close request to the server. So here you can say at the fifth step, a connection close request is sent to the server saying that I want to end the connection with you, and at that time the server will be sending a response saying that yes, the connection will be closed with you. So at that time the connection will be lost between the client and the server, and the communication will end here. So this is our exclusive pair communication model. So why it is called as exclusive pair? Exclusive pair because a single client is connecting with a single server through a single link here. So we are especially a link will be shared between client and server, that will be not shared with any other client. So server will be giving a particular link to a particular client, so that link will be not shared with other client until and unless it is freed from one client here. So that's why it is called as an exclusive pair. That is means a VIP type of a link which is present between client and a server. Alright, so coming to the points which are listed here, exclusive pair is a bidirectional, that is fully, so client and server can talk at a time. So it is not needed that only at a time client should talk, or only at a time server should talk. So they can talk simultaneously. So it is like a telephone communication, we can say. Then fully duplex, that's the meaning of fully duplex, both way communication or a bidirectional communication, and model that uses a persistent connection between the client and the server. And then once the connection is set up, it opens until the client sends a request to close. So once the, as I said, once the connection is made, until and unless it will be the server will not receive a request from the client saying that I want to end the connection. At that until that, the server is not going to lose the connection between the client and a server. So client and server can send messages to each other after connection setup. So as I said, they can send after once the connection is set up between them. So this is how exclusive pair communication model works, and that's all for the IoT communication models. That is these four types of communication models, and I hope you like this video. Please guys, please if you are new to the channel, subscribe the channel and like the video.